Welcome to the physics of living energy. Before exploring the engineering Ankh, we begin with the foundations of electrical science. Electricity powers modern civilization because it follows consistent physical laws. By understanding those laws, we gain a vocabulary for discussing energy systems with precision. Throughout this presentation, each scientific principle builds toward a conceptual engineering model of the Ankh. Electricity is the movement of electric charge. In most conductors, that charge is carried by electrons. A complete conductive pathway allows charge to move from one point to another, creating useful work such as light, motion, heat, or communication. Every electrical system begins with the controlled movement of charge. Voltage is electrical potential difference. It represents the force that pushes charge through a conductor. Without voltage, there is no motivation for current to flow. Engineers often think of voltage as stored electrical pressure that becomes useful when a complete circuit is available. Current is the rate at which electric charge moves through a conductor. It is measured in amperes and exists only when a complete electrical path is present. The amount of current depends on both the available voltage and the resistance of the circuit. Materials differ in their ability to conduct electricity. Metals, such as copper and silver, allow electrons to move freely, while rubber, glass, and ceramics resist electron flow. Engineers carefully combine conductors and insulators to move energy safely and efficiently. Resistance opposes current flow. Every conductor possesses some resistance, causing energy to be converted into heat. By selecting appropriate resistance values, engineers protect equipment, regulate current, and control electrical performance. Ohm's law expresses one of the most important relationships in electrical engineering. Voltage equals current multiplied by resistance. Changing any one of these values affects the other two, making this equation fundamental to circuit design and analysis. Alternating current periodically reverses direction while maintaining continuous energy transfer. This property makes AC highly efficient for long-distance electrical transmission and explains why it powers homes, industries, and modern infrastructure. Resonance occurs when an external force matches the natural frequency of a system. Under these conditions, energy transfers with exceptional efficiency. Resonance is used in communications, medical imaging, structural engineering, and countless electronic devices. Electric and magnetic fields are inseparable aspects of electromagnetism. A changing electric field produces a magnetic field, and a changing magnetic field produces an electric field. Together, they allow energy and information to move across space as electromagnetic waves. Electromagnetic induction converts motion into electricity. When a magnetic field changes around a conductor, voltage is induced. This single principle makes generators, transformers, and the electrical power grid possible. Capacitors temporarily store electrical energy within an electric field between conductive plates. They release that stored energy when required, making them essential for filtering, timing, energy stabilization, and countless electronic applications. Frequency measures how many complete cycles occur each second. Measured in hertz, frequency determines the behavior of alternating current, radio transmissions, sound, and light. Matching frequency allows systems to communicate and operate efficiently. Bioelectricity describes the electrical activity naturally present within living organisms. The heart, brain, nervous system, and muscles all rely upon precisely coordinated electrical signals. Modern medicine measures these signals to better understand health and physiological function. The engineering Ankh brings together the electrical concepts explored throughout this presentation into a conceptual visualization. Its internal pathways represent organized energy flow, demonstrating how engineering language can be used to illustrate coherence, circulation, storage, and balanced distribution of energy within a unified symbolic framework.